Let's take a look at the electronic structures of atoms. 原子的电子结构 Elements are determined by atomic numbers, each of which equal proton number and the electron number of each atom of a given element. 元素由原子序数决定，每个原子序数等于给定元素的质子数和电子数。Chemical properties are determined by the number of electrons of an element. 化学性质取决于元素的电子数。Electrons do not move around freely. They are confined in a specific area corresponding to their energy level. 电子不能自由移动，它们被限制在与其能量水平相对应的特定区域。Energy of electrons is quantized. Electrons occupy spaces based on their energy level. The electron-occupied spaces are called shells. The distance of the shells to the nucleus corresponds to the electron energy level. The closer the shell is to its nucleus, the weaker the energy of the electrons. The farther a shell is from the nucleus, the stronger the energy the electrons. 电子的能量呢是量子化的，电子根据其能级占据空间，电子占据的空间称为克层，其到原子核的距离呢对应于电子能量，克离核越近，电子的能量越弱，克离核越远，电子能量越高。The farther a shell is from the nucleus, the larger the volume becomes, and the more electrons it can hold. The maximum number of electrons is given by the formula 2n to the power of 2, or 2n squared to the 2n to the power 2 squared, where the n is the shell number. 克离原子核越远，它的体积就越大，它可以容纳电子的就越多。最大电子数是由公式 2n 2的2次方给出，其中这个 n 呢是克数。Take a look at this number. This on the left side is the shell level 克层。On the right side is the electron numbers, maximum electron number. The first shell has a maximum of 2 electrons. The second one has 8 electrons. Third one 18, and the fourth one 32. Those electrons can be calculated using this formula. Shells are divided into subshells. Subshells include S, P, D, F. Energy levels of subshells: S 小于 S, smaller than P, P smaller than D, D smaller than F. The number of subshells in a given shell equals the volume, equals the value of the shell number n. The first shell has only one subshell, S. The second shell has two subshells, S and P. The third shell has three subshells, S, P and D. 克分为子克，子克是 S P D F， 子克的等级S 小于 P 小于 D 小于 F。给定外壳中的子外壳数呢，等于这个外壳的编号的 n 的值。第一个壳只有一个子壳，这个子壳是 S。第二个外壳呢有两个子外壳 S and P。第三个呢壳呢有三个子壳S, P and D。The subshells consist of orbitals. Each orbital can hold two electrons called electron pairs. Each type of subshells contain a specific number of orbitals. 亚壳由轨道组成，每个轨道可以容纳两个电子，称为电子对。每种类型的子壳都含有特定数量的轨道。Take a look at this. This subshell SPDF. The number of orbitals. S subshell has only one orbital, and P has 3, D has 5, F has 7. Then you can calculate the maximum number of electrons: 2, 6, 10, 14. Let's take a look at the summary of electronic structure, 电子结构总结。Shell, subshell, orbitals, electrons in subshells and electrons in shells. Okay, the first shell has one subshell S, has one orbital, 1s, has two electrons in 子壳 in subshells, and because it's only one subshell, the total electron number in shell also is 2. The second shell, two subshells, and 4 orbitals, 2s, 2p, 2d, this 2d. The 2p has 3 orbitals. Okay, the 2p, 3 2p orbitals, 1 2s, and 3 2p's. So each subshell has 8 electrons, 2 plus 6, 8. This subshell 2s has 2, and this p has 6. The total is 8 here. The third shell has 3 subshells. This is 5, 8, 9 orbitals. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 3s, 3 3p, and 5 3d. These the electrons in subshells. The S has 2, P has 6, and the D has 10. The total 18. Number 4. The fourth shell has 4 subshells, and you can see a large number of orbitals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. And then you can calculate you can see this the electrons in each subshell. 2, 6, 10, 14. The total is 32. Let's take a look at the orbital shapes. 轨道形状。S orbital is a sphere shape, is 球形。Pay attention to the size. 给each subshell has all the subshell has the s orbitals, but the s orbitals on different subshells has different size. This is 1s. Let's say this is 1s, this is 2s, this is 3s. This 2s is bigger than 1s, 3s bigger than 2s. P orbitals look like a dumbbell shape. Dumbbell 是中文是哑铃啊 ，dumbbell shape. 3 2p orbitals are perpendicular 是垂直的 to each other along x, y, z axis. 这是三个轴线。P 轨道是哑铃形，三个2p 轨道沿着 x, y and z 轴相互垂直，是垂直型的。Put all together, you can see this sphere here is s orbital, and you can see 3 p orbitals in different colors. This one is kind of red, this is blue, this is yellow. The shapes of orbitals on different shells are different. For example, 2p orbital and 3p orbitals have different shapes. Although they both look like a dumbbell, but they still have different. The dumbbell and dumbbell are different on different subshells. 2p and 3p are different. 不同壳腔的轨道形状是不同的，因此这个比如说这个 2p 的轨道和 3p 的轨道的形状不同。Those electrons move on. Those electrons move on the corresponding orbitals surrounding the nucleus from forming an electron cloud. Electron cloud, this is a new concept. 这些电子呢围绕电子核的相应轨道移动，形成电子云。Crystal 3D structure of a molecule such as a protein are determined by tracing the electron clouds, also called the electron density map, which represents the structure of a molecule. And you can see this is the electron map here. Then this is the chemical residues, amino acid residues, and feed into this density map, electron density map. First, they calculate this density map, then feed in using the shape to feed in different molecules, different compound molecules. In protein, for the protein, those molecules are amino acid residues. 这个分子，比如说它蛋白质的晶体，3D 晶体结构是通过最终代表分子结构的电子云、电子密度图来确定的。